This is a video about the equation of a line and how you can make the equation of a line from a graph. Method 1 sees us using the y-intercept and the slope to make the equation. When we get the equation this way, we use the formula y equals mx plus c. M is the slope, c is the y-intercept, and y and x just get left as y and x. When I look at this diagram, it's very easy to see the y-intercept. The y-intercept is just the number that the line passes through on the y-axis, and this line here is clearly passing through the point 1. So I've got a y-intercept of 1 in this case. To get the slope, I'll need to use rise over run, which it's easy to do in this question because I have a grid in the background of the diagram. To do this, I'll pick 2 points on the line that are definitely at the vertex of the grid. So, for example, this point here is at the vertex of the grid, or at a vertex of the grid, because it's right in the corner of one of the boxes in the grid. And if I move along up to here, for example, I'm also in the corner of one of the boxes that make up the grid. I draw in my run and my rise. The run is the horizontal distance and the rise is the vertical distance. I can see that my run is 2 and my rise is 4. So rise over run in this case is 4 over 2, and I can work that out. 4 over 2 is just 2. So I now know that when I want to make the equation of this line, that I need to put 2 in for the slope and 1 in for the y-intercept. So the equation of this line is y equals 2x plus 1. Let's look at a second example of the same type. So again, I want to find the equation of this line. So since I've got a diagram and I've got a grid in the background of the diagram, and because of that I can see the y-intercept and I can do my rise over run for slope, I'm going to use the same method as I used in my first example. So I'm using the formula y equals mx plus c. The m is the slope and the c is the y-intercept. Take a moment here to identify the y-intercept yourself. You can see it's 3, that's where I'm going through the y-axis. To get the slope, I have to draw in my triangle to find rise and run. First, I must identify 2 points on my line that are at the corner of one of the boxes in the grid. So I'm going to use my y-intercept as one of those, and I'm going to use this point here as another one. And I'm going to draw in my triangle, and now I'll write in my rise and my run. Now, in this case, my line is dropping down. So I've had to come down on the line to get to this next point. So my rise, even though it's called a rise, is actually really a drop. And because I'm dropping down, I give a negative value for that, so it's -1. And then my run is 3 boxes across, so it's a value of 3. So my m, my slope in this case, my rise over run, is -1 over 3. And that's absolutely fine to have it in a fraction, that's no problem. So now I'll write the equation of my line, and I can write it as y equals -1/3 x plus 3. Method 2 will involve using 2 points on the graph. You can see in this case that I have no background grid, so I'm not going to be able to use rise over run to get slope, and I'm also not told exactly where the line goes through the y-axis, so I don't have a y-intercept. I do, however, have 2 points, and I can use 2 points to get the equation of a line. When I have any 2 points, I can always use the formula y minus y1 equals m times x minus x1 to get the equation. Of course, I can't use rise over run to get the slope, but there's a formula for that, which is m equals y2 minus y1 over x2 minus x1. We start by getting the slope. First, we'll write our 2 points down and we'll label them x1, y1, x2, y2. This is so that I know where to put them in the formula for slope. Now I'll fill into the slope formula. So here's y2, it goes in first, and then I minus y1. On the bottom, I've got x2, and now I need to minus x1. Watch out here, this x1 is a negative. I need to include the negative from the formula and the negative from the x1. I can type this calculation into the calculator, and in this case the slope comes out as 1. Now I use the equation formula. For the equation formula, I need a point and I need a slope. Now, I need 2 points on this line, so I can choose whichever one I want, and generally pick the one that looks a bit easier. I'm going to use 1, 5 this time, and my slope is 1. And again, before I begin to fill anything in, I'm going to label these. I've only got 1 point now for the equation, so I'm labeling it x1, y1, and I label my slope as m. And now I'll fill this information into my formula for the equation of the line. The y and the x just stay as y and x. So when I fill in, it'll look like this. y minus y1 first, which in this case is y minus 5, equals to m, which is my slope, in this case that's 1, times x minus x1. Now I'd like to tidy this up a little bit, because even though I've used this formula, I do like to try and write my final equation in the form y equals mx plus c, but that's pretty easy to do. I'll start by multiplying out the bracket on the right hand side. There's nothing to do on the left, I can leave it exactly as it is. So I'll get y minus 5 equals, well, 1 by x is 1x, and 1 by minus 1 is minus 1. I've got a little bit more to do. I want to get it in the form y equals mx plus c, so I only want to have a y on the left hand side. That means this minus 5 has to come across. And don't forget, if it's a minus 5 here, it's going to add on the right hand side. I can simplify now to get y equals 1x plus 4. And note, just like in our previous method, the coefficient of the x represents the slope, and the constant at the end of the equation represents the y-intercept. When we're making the equation of a line using 2 points, we may be given a graph like we were in this question, or we might just be given the 2 points written down in the question. We'd follow the same procedure in either case.